Hey Year 7s, Mr. Herman here, and this video is going to be looking at the skill set of conducting chance experiments. And there's quite a bit of information with this skill. It kind of jumps into a very murky territory. So before I show you some examples from Essential Assessment, I just want to do a little breakdown between the difference between theoretical probability and experimental probability, because these are the type of questions or terminology you will get within the questions, and if you don't know the basis between the two or the difference, it's hard to tackle the questions. Hopefully by now you should be comfortable with working out probabilities in the form of decimals, fractions and percentages, and right now we're going to expand on those skills and talk about real life situations where we use probabilities. So the first thing we're going to look at is theoretical probability, okay? And theoretical probability, in other terms, it just means what we expect, okay? And to expect something is to predict something, okay? To make a prediction or an assumption of some sort. And these expectations come from probabilities themselves. The best way to look into this is to think of an example where I have a coin. Okay, let's do the most simplest form where I have a coin. Okay, and we know there are two sides to a coin, heads and tails. Okay, heads and tails. And I flip this coin, and we know that there's a 50% chance of it landing on one or the other. Okay, or a half chance. And then I said to you, okay, if I were to flip this coin 10 times, so I flip this coin 10 times. If I were to flip it 10 times, based on theoretical probability, how many tails am I expecting? How many tails am I expecting? And intuitively you'll say, that's easy. That's if we're expecting half of tails to appear every single time, then half of 10 is 5. So I'm expecting in this case 5 tails. And if you were to think of it in that format, you are absolutely right. That is correct. You expect 5 tails. And how you would do that is you would just find 50% of 10, or in the calculator, if you were to get the calculator out, you would just work out half, so 1/2, and just times this by how many trials that we're conducting, in this case 10. And so the answer here is 5. Okay, now these percentages or probabilities will change depending on the context, and the amount of trials that changed also depends on the context as well, but the format will still remain the same. It will be the fraction of the probability multiplied by the amount of the trials. So in this case we're expecting 5 tails. Now you've got to remember that this is theoretical, okay? And to theoretically or to theorize on something is to say, hey, we're making a prediction based on the probabilities that we know, and the probabilities we do know is that there's a 1 in 2 chance of getting either one of these sides. Okay, so theoretical probability is a probability that we're used to. It's a probability that we know how to obtain. If this were to happen 200 times, how many tails are we expecting? Well, we're expecting half of them to be tails, so we're expecting half of 200, which is 100. Okay, now theoretical probability, if we were actually to conduct this experiment and flip a coin, in this case 10 times, we might not get exactly 5 tails. Okay, we might be very close to it, but realistically, if every single student in 703 were to do this, not every single person will get 5 tails. It'll be awesome to see that. But chances are, when we conduct this experiment, you'll either be equal to, very close to, or not close at all to the expected amount from our theoretical probability. Okay, and this is what experimental probability is. It's the results from the trial. Okay, so our trial in this previous example is flipping a coin 10 times, but the actual result, you might get maybe 3 sets of heads and maybe 7 sets of tails. Okay, which is sort of close. Okay, something that's not close is maybe getting 0 heads and 10 tails. Okay, that's not close at all. Okay, experimental probability is actually experimenting with the trial itself and trying to see what your results are based on what we want to find out. Okay, if we were to get something that's not close to the theoretical probability or the expectation, we then say that there could be a bias form of answer. So in this case, there might be a biased coin, and bias just means to favor one side as opposed to the other, and there's no equal share between one or the other. Okay, and that's what bias means. So if we have a biased coin, that would mean our result is not close to the theoretical expectation. Okay, 0 heads and 10 tails. If we flip a coin 10 times, that seems very far-fetched. I reckon there could be some bias to the coin. Maybe the coin's weighted, we don't know. Okay, now that you've got some insight with this, we're now going to look at the questions that we get here, and just be mindful that these questions, they're quite intense and they're quite word heavy. Okay, I'll break down some of these questions and show you how to answer them. Okay, so this is one of the first examples that you will get, or one of the first questions that you will get on this skill, and I've just taken a snapshot of this ready to write on. And the question is, a coin was tossed 10 times, landing on heads 8 times and tails 2 times. Based on theoretical probability, so predictions or expectations, which would be closest, and there's a key clue here, which one will be closest to the expected results if the coin was tossed a further 90 times? So let's try to dissect as much information as we can from this. So theoretical probability just means that we're expecting 50% of them to be the head and 50% of them to be the tail. Okay, or half chance. So in fraction form, it's half. So we don't necessarily care about what the experiment is. 8 times for heads and then 2 times for tails. We just need to work out what's closest to the theoretical probability. So the coin was tossed 10 times, and then it's going to be further tossed 90 times. So all up, there are going to be 100 tosses for this. The coin flipped 100 times. Okay. Then we're expecting from theoretical probability that half of them, 50 of them will be heads and 50 of them will be tails. Okay, that's based on theoretical probability. But then a lot of students get to this point and say, hold on a second, that answer is not provided here. And the reason why is because the question specifically says which one would be closest to. So the closest one in this case is 55 heads and 45 tails. So this one here would be the correct answer. Another question you will get from this skill is now based on experimental probability, which is different to the theoretical one. And the question says a standard die was rolled 6 times with the results shown below. Based on experimental probability, what is the probability of landing on the number 4? So based on experimental probability, just means based on the trial that was just conducted. This trial right here, okay? If it was theoretical, we wouldn't really rely on this trial, but it is experimental, so we need to obtain this information to get our probability. So the die was rolled 6 times, and from those 6 times, 1, 2, 3, 4, 5 of them landed on the number 4. Because it's asking, what is the probability on landing on the number 4? Well, that's 5 out of 6 times. If you did want to think of this as theoretical probability, theoretically, we would be expecting the number 4 to land on the dice, after 6 rolls to land on the number 4 at least 1 out of those 6 times, because there are 6 sides to a dice and there's only 1 4. But based on this, you can say that maybe we were just extremely lucky with this roll, or that the dice right here are biased. It's weighted in some form, one way or another. We're now going to look at this question here, and this has to do with what's called a frequency table. And a frequency just means total amount or a count of some sort for that specific outcome. Okay, so the question says a spinner was used 10 times. So this spinner right here was spun around 10 times with the results shown below here within the experiment results table. Based on experimental probability, what is a probability of landing on orange? Now I'm actually going to do question 8, and question 9 asks the same question, but they ask it in the form of theoretical probability, but I thought I'll just put both of them on the same page here. So based on experimental probability, we're just using this trial here. So they spun it 10 times. Out of that, how many of them landed on orange? Well, the amount that landed on orange was 7. And the amount of trials that were conducted was the total amount here, 7, 8, 9, 10. And it even says it in the question here, it was used 10 times. Right here. So experimental probability is really simple because you're just obtaining information from a results table which is readily given to you. But theoretical probability is a little bit different. Let's say we change this and it said, based on theoretical probability, what is the probability of landing on orange if it was spun 10 times? So the first thing we need to do is get the probability of landing on orange from the spinner here. We know that there are 3 oranges within the spinner, and all up there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 counters or wedges all up. Now if we are to spin this 10 times, we're just going to get this fraction and multiply it by 10. And so on your calculator, you would just put the fraction form 3 over 10 and multiply this by 10. And you should get the answer of 3. Okay, so theoretical probability, in this case, we're expecting it 3 times, but the theoretical probability is actually just asking for a probability. So I actually didn't need to work this out. I kind of jumped the gun here. In this case, it's 3 out of 10. But if they said theoretically, how many are you expecting? That's when you would answer the number 3. The last question or example that we'll be looking at focuses on a different scenario that have been given to you. In this scenario here, we've got 4 different samples of marbles, and these have been selected at random from a box. Which sample are you most likely to select a red marble? Now this answer here has shown you that this is the correct one. We want to try to figure out why. Why is this the case? And what you do is you just have to work out the percentage of choosing a red marble from each of these scenarios. So the first thing you do is you find the fraction of obtaining a red for the first scenario. So this is a 1 in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a 1 in 10 chance, or 10%. Now again, if you want to double check this on your calculator, you would put 1 over 10 and just times this by 100 to get your percentage. So it's 10%. In this case here, we have 3 out of 6, which is 50%, which is a high percentage. Here we have 1 out of 1, 2, 3, 4, 5, 6, 7, 8. So this as a percentage, 1 over 8 times 100. And this is, so here we have the scenario where it's still given to me as a fraction format, and this is where we use that SD button to get 12.5. So this is 12.5%. And the last one here is a 2 out of 5. And this is a 40%. You can use your calculator to double check that. And so from this, the likelihood of, or the scenario where you're more likely to choose a red marble is this one here. It doesn't necessarily mean that if you chose that sample, you would definitely get a red. It just means this is the best scenario for you to choose. And that concludes this lesson. Go ahead and work on the skill, and I'll see you guys in the next video. Bye-bye.